Hi guys, in today's video we'll be examining how did we get the quadratic formula and just a little bit of some history of it. We use it whenever powers of 2 are generally involved in math class, so we should at least understand where it came from. So let's get right into it. Now then, we have the general, I guess you could say, structure of a quadratic equation, and what we're going to be doing is we're going to derive the quadratic formula from it. Now, some of you may scoff at that, saying that, formulas, but formulas are super important because they can minimize the amount of work we have to do to get x, right? Instead of going through such long processes, all you have to do is just plug in the coefficients and the constants into the formula, and you get your roots right there. But it's important to understand where we get it from. So the first one we're going to do is we're going to divide everything by a. Okay, I'm sure you can understand why we want to get x by itself, so we should at least get rid of the coefficient in front of the first x squared first. So we're going to have now x squared plus b over a x plus c over a equals 0. Next, from there, what we're going to do is we're going to subtract c over a from both sides. So we can do that right there. I'll put this in a different color to show the different operations going on. So c minus a, c over a, and then what we have remaining is x squared plus b over a x equals negative c over a. So really there's nothing too difficult going on here. It's pretty straightforward. But this is where it gets interesting, and this really shows the creativity of, say, the ancient Indians and the ancient Babylonians, Egyptians, Chinese. Really, this formula is really a big amalgamation of a lot of different cultures and their thinkings back more than 1,000 years ago. So it really goes to show how critically these people thought back then. Usually we think of the formula these days as just something that just came out of the blue, but no, it's a big process that's been going on for 1,000 years. And with that being said, the thing I want to talk about is completing the square. Now, we might know completing the square as taking the b value of something, dividing it by 2, and then squaring it. And really, we undermine the importance of what it really means, because people back then, more than 1,000 years ago, like the ancient Indians, they found that, oh, we can kind of shorten a quadratic equation into simply x plus some value y, and then square that. And in this way, you get x isolated instead of something maybe like x plus, I don't know, a and x plus b, right? X plus b. Now, in this case, we have two x's, but what people realized back then was you can put it as just one expression here that you can square, and then you can take the square root of that, and you can subtract that to get x by itself, and that is exactly what we're going to do soon. So in this case, b in this little completing the square, I guess you could say, like, formula right here, that would technically be b over a. So b over a, b over a divided that by 2, and then squaring that. Well, let's see here. B over a divided by 2 is the same as b over a divided by 2 is the same as multiplying by 1 over half. So we have b over 2a. Then we gotta square that, which is the same thing as b squared over 4a squared. Now we're going to add that to both sides. So I'm going to come down a little bit here for more space. So we have x squared plus b over a b over a plus b squared over 4a2 equals b squared 4a squared minus c over a. Now you remember what I was talking about when we could abbreviate it as this? Well, that's what we're going to do on the left-hand side of the equal sign. So instead of writing all of this, we can just condense this into x plus. Now what are we going to add this with? Well, we're going to add this with b over a divided by 2. It's this value here, b over 2a, before we squared. So b over 2a now equals b squared over 4ac minus c over a. Now the next thing we're going to do is we're going to combine these two terms. So we need to get common denominators. So to get, sorry, this would not be a c, this would be 4a squared. Apologies. 4a squared. So to get 4a squared on both sides, we're just going to multiply by 4a here and 4a here. Now we're going to have, I put a square there. Now we're going to have x plus b over 2a squared equals b squared minus 4ac over 4a squared. When you combine these, now you might see the makings of the determinant in the quadratic equation. This part here will determine if you have real numbers, if you have complex roots or real roots. And this is one of the things ancient Indians saw. You know, the ancient Indians contributed the idea of a zero. Anything less than 0 in the determinant would become a complex number, and anything above a 0 would be a real root. So we're going to go ahead and take the square root of both sides now. So doing that, we get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a, because you can take the square root of this. The square root of 4 is 2, and the square root of a squared is just a. Now, finally, all we have to do is subtract b over 2a from both sides, and we get our famous quadratic equation. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And one more thing, this plus or minus has a significance. It tells us that there could be possibly two answers to a quadratic equation, not just one but two. And this is really great stuff that we're seeing here, guys, because like you always think that there might be a single answer to something, but there might not be. There might be multiple answers to the same thing, and they might both work. So this equation that this formula that we see here wasn't really discovered until the mid-1500s by European mathematicians. But even just seeing it 500 years ago is still a big feat that probably we could not even imagine to do today. So I hope that helped. This is a very important equation, really. Alright guys, if you guys enjoyed the video, go ahead, leave a like, subscribe, and comment down any questions that you might have. I'll see you in the next one. Bye.